The next one we're going to do is lowest common ancestor of a binary tree. Sounds like we're going to be pulling out our tree node code again. Given a binary tree, find the lowest common ancestor of two given nodes in the tree. Lowest common ancestor is defined between two nodes P and Q as the lowest node in T, the tree, I guess, that has both P and Q as descendants, where we allow a node to be a descendant of itself. Okay, so given this tree here, 351620874, and P is 5, and Q is 1, the lowest common ancestor is 3. Okay, that makes sense. Next example, we're given 5 and 4, and so the output is 5. Okay, and then we do have one more example without a drawing. Root just has 1 and 2. So the root node is 1, and it has a single node 2 as the child. So the lowest common ancestor is 1. Okay, and I'm assuming they mean by lowest common ancestor the closest node in the tree, not the lowest value node, right? That wouldn't make any sense. All right, and then what do we look like here? Okay, so let's start off by creating our. It's been a while, so things are a little slow. Here we go, lib. Okay. I don't know why I couldn't find it, or I overlooked it, or whatever. So we're on 236. So 0236, lowest common ancestor of a binary tree. So the difference between 235 and 236 is one's a binary search tree, which means things are organized. Every node on the left is less than the current node, and every node on the right is greater than the current node. So we can take a look at that code real quick. Let's do this first and just get this to build. Copy the code out, paste it in here, and then let's take a look real quick at this one. We can grab that line there. And it's just lowest common ancestor. Where's solution? Oh. Huh. Oh, I did it. I didn't do it inside the solution struct. Okay. But this was easy because we could just figure out. Oh, we found a path. Okay. Yeah. And so because we're able to just find it based on the target value. Here we actually have to actually look at the nodes themselves. Okay. So what are we returning here? An option. So let's just put a none in here and see if this builds. Oh, right. We got to get their tests going. And I have to do pub struct solution. Wow. There you go. Right, and then run tests. Okay, so the first test is, let's throw in here as example 1, is this. So test mod, test ex1. So we're expecting the output of 3. Oh, no, we're not expecting an output of 3. We're expecting an option RC ref cell tree node output. Huh, okay, so that's going to change things a little bit. What we can do, though, is we can say let tree is equal to tree node, I think it's from vec bang, paste. Oops, that was dumb. Come over here, copy, paste. And these nulls turn into I32 min. Right, and then we're going to do a, oh, I see. We're actually passing in a ref. Oh, are all the values unique? Yes. Okay. All node values are unique. Okay. So we can just, I guess, make a tree node with P and Q. Let P tree node from vec bang example 1 is 5, and then Q is 1, right? And then we can pass that in here. We can say solution lowest common ancestor. Actually, we do it here. Let result is equal to solution lowest common ancestor of tree P and Q, and then we'll say result dot. We have to unwrap it for the option. We have to borrow it for the ref cell, and then we have to get the value of the node. Let's take a really quick look at this code. It's just called val. Okay, easy enough. Val. All right, so that's our first test, and then the second test should be very, very similar, right? Oops. These have to be refs. Okay. Easy enough. All right, and now it failed, right? Because we're passing back a none. That's fine. So, but our test compiles. So, and let's do the other test, other two tests while we're here. So let's grab this, copy. Let's copy those lines, test ex2, paste those lines, and then I'm going to change this to this. Is it the same? Looks like it's the same. I didn't have to do that. Okay, now 5 and 4. We do the search, and now the answer is 5. Okay, and then finally, example 3, which is very, very simple. Test ex3. Oop. Copy, paste. This is just a 1, 2. And all 3 tests should fail now. Good. All right, now all we need to do is write the code. So the way, let's take a lowest. Yeah, let's take a look at this again. So what I did was I created a separate function to do the actual search. And I have printlns in here. I don't know why I did that. Must have been debugging. Oh, because I'm finding the path. I got it. Okay. So I think we do something similar here. Find node. Because this way I can pass in references to option RC ref cell tree node. And I don't have to clone the tree each time. And I think what we can get away with, since every value is unique, we don't need to pass around the entire tree. Because here's the thing, is if this P and this Q are both full trees, right? So we would have to clone them every time we recurse down, and I don't want to do that. But we can just say, just call them I32s, just pull the I32s out. And then this returns, does this return an option RC ref cell tree node reference? Right, and then this, we can't return an option. Yeah, let's just return root for now. I was going to say return none, but how do you return a none in this case? I don't think you can. You'd have to return a reference to none, which won't work because we're passing, it didn't complain. And because it's not being called? Well, here's what we're going to do. Let result is equal to self find root p dot unwrap dot borrow dot val and q dot unwrap dot borrow dot val. And that should be a reference to something. Find node. A reference to something in there, and then we should be able to return results.clone. All right, let's see what happens there. Okay. Yeah, and result is none, so we're panicking. So we can return a reference to this. Okay, that's if we don't find it. So that's what we have to do. Let's see now so our stopping condition is if this node is none. So I can say if let some node equals root else none. And I can just return root node here. Oh, it's already a reference. Okay. Some node. Reference to some node. Yeah, okay. Right. So we still need to, because this is a reference to an RC ref cell tree node. What I wanted to return was basically a pointer into, maybe, I was thinking maybe we could do this, but then we can't return a none if we didn't find something. What if we turn an option to a reference to an RC ref cell? What if we do that? Right, and then we can do that. And that way we can actually find the thing. Oh, that's interesting. Do an unwrap clone. This says clone cloned. Can we just clone it like that directly? We can. Okay. Okay. So then it's finding the wrong node, right? Because it's finding 3 because we're just returning the first one. Okay, so I think we have the borrow checker happy now, right? And we only have to clone once so far. And hopefully that'll be true for the rest of this. So how do we find the lowest common ancestor of a tree? Now we're actually to the meat of the problem, now that the setup is done. So you search to the left to see if you can find a P or a Q. And you search to the right and see if you can find a P or a Q. If you found a P or a Q, then you found a node that's in common, and you can return yourself. Then the one you're processing is the one that's in common. Let's do it this way. So what we can do, we can say if node borrow val is equal to P. Oops. The borrow goes here, right? Val is equal to P, or node borrow val is equal to Q. In other words, did we find a P or a Q? And if so, then we can return some node, right? Because we found a P or we found a Q, and so our node is this. So we're done with the search down this part of the tree. So now, if we're not at a P or a Q, that means we must be above it somewhere, right? Because we'll stop as soon as we'll hit a P or a Q, right? We won't look at 6, right? Because, yeah, we won't look at 6. We won't look at 1 because it's below. So we're going to say we're going to say let left is self find node of, and now node is, I forget what type it is. I wonder if we can get away with, because I want to pass node down, but I don't want to have to say some node. Dot left. Oh, that's right. We can just say node dot left, right? Because node dot left is an option RC ref cell, and it exactly matches that. Perfect. A reference to option RC ref cell. So then P and Q, right? So this is what we do, and then for right. And now we look to see. So if we're finding if we found a node that we were looking for, then we stop. If we haven't found a node we're looking for, let's look at this example here where we're looking for 5 and 4. Then we'll look to the left and we'll look to the right. And now this can be either nones, right? We didn't find anything on the left side, or we didn't find anything on the right side. Or they could be a pointer to a, reference to a node. Right, so we can say match, left, right. If it's none, none, we're going to return none. Kolhoti, hello. And Jewel Wayne, thank you for the sub. Thank you for that Prime sub. Much appreciated. Kolhoti says, are you okay? I am fine. How are you? The other thing it could be is anything, right? If we found something on the right, which is not none. I don't want to say some foo, because that might cause us issues. We already have the right value. If we found it on the right-hand side, then that's what we'll return, which return right. Right? That's an option, blah, blah, blah. If we found it on the left, then let's return our left one. And if we, everything else, which means we have a left and a right, both of them, that means we're the common one, right? So now we just return node. Root. Oh, we can't return root. We can return node. Yeah. All right. Does this build? No, of course not. Unknown field. Oh, node dot left. We can't do node dot left. We had node borrow left. Expected reference found enum option. And you're right, we can't return this because this is not an option something, but we can say some node, right? Which is root. No, root is different. Root is a reference to an option, and node is a reference to an RC, and so we can say some node. And now it won't let me do that. Right. Okay. So, am I going to have to clone my way out of this? Okay, this returns a reference to referencing data owned. Is it because I'm passing this in, but I'm getting back an option this. Do I have to like unwrap and sum it like that? This is what I mean by I'm still very much a beginner at Rust. Yeah, it's saying temporary value created here. We're just borrowing this. Oh, it thinks that we're gonna. I see. I might have to just clone my way out of this problem, which is going to be annoying because we'd be cloning whole trees. What if I do it this way? Can I do this? if I do that, that's an option RC ref cell. Now I can just say left this way. Doing it in 2 steps? No. Oh, wait. The underlines show up here, but this is, what if I can do it this way? This doesn't need to be a reference anymore, right? Like that. Yeah, no, it's pointing here. Yeah, so temporary value is created here. I don't see why it's temporary though, because we're just creating a reference to something that we already own. And Rust should know that the lifetime on this guy is the same as, oh, maybe it doesn't. Maybe it doesn't. Maybe I can lifetime my way out of this. Nope. Yeah, I assumed that this, Rust assumed the right lifetime info, so nothing changed. Can I do, what if I do this? Borrow write clone. Yeah, I didn't want to clone my way out of it, but that might be the way we have to do things. And then this is still that. Will that work? Or is it on this problem? Write is borrowed. So write is borrowed here. But we're done. We stopped borrowing it. Oh, Does this mean that write is still owned by? Yeah, it probably does. Okay. So then maybe we abandon this whole idea and we just return like this, which makes it, it means we have to clone everywhere, which is unfortunate. So this doesn't change. Oh, yeah, it does. We'll say root clone here. Because now root is the option RC ref cell. And we have reference to one, and we have to clone our way out of that. Right. Oh, then we don't actually need to clone this. Right. Because it's returning the right type, which means we don't even need a result. Okay. We're getting there. And now this, do I want to do it this way now, or I should be able to put it in line now, right? Because we're gonna just borrow it. So let's just node borrow left and node borrow right, and then this one becomes yeah, ourselves. Node clone. Nope. Oh, right. Now these, oh, okay. Oh boy. Root clone. There. Wow. Okay. So we got it. All our tests are passing now, which is great. Which means we can probably throw this code at Leetlib and see what happens. Paste. I'm not satisfied and not unsatisfied. Okay, so that worked. In terms of runtime, it's pretty fast. In terms of memory, it's not great, but I'll live with it. Yeah, it's all this cloning stuff. I was hoping I could find a solution where, in which we could just borrow everything and just keep pointing into the node, but returning the values was difficult for me to figure out how to do. So now we ended up, so we clone anything we find that's successful, we clone out. This is not, yeah, so this is basically a clone because the find node will return a clone here. Well, It'd be nice to be able to do it without any clones. You should be able to, right? You should be able to just reference the tree nodes themselves without making any copies of them. I don't know how to do that though. This is what I mean when I say I'm a Rust beginner. I'd love to see a solution that does the right thing. Get status. Let's go over here and do Clippy. Okay. Git add source. Git commit -m problem 236. Lowest common ancestor of a binary tree. Good. Let's tick that box or check that circle.